Welcome to the Math Live class. My name is April Barton. I may or may not be your specific math teacher. There's 3 math teachers here. So you could have Karen Whitehead, or you might have Janae Russell. There's a couple math teachers, but you're welcome to send me emails and ask me questions if you want, or you can send your own teacher chats and ask questions as you work through the course. So today we're going to talk about relations for 15 minutes. I'll take just general questions, things you want to talk about, and then 15 minutes on rate of change, and then another section of general questions. So relations are making an equation that relates 2 things together. We want to actually take something in real life and apply math to it. The reason we would even want to do that is maybe to make a prediction. If you know some information, you can say, well, in the future, this should happen. And I know that because I made an equation about it. So I gave 2 examples. Example 1, how far you drive and your height. So does how far you drive have anything to do with how tall or how short you are? And remember, you can answer by either unmuting yourself and answering or finding the chat box and typing into that. Does driving have anything to do with height? It doesn't. Good. That is correct. No, there's no relation. Good. So no correlation. We literally can't make a relation for this. They're just not related. A relation has to make sense. There has to be some sort of correlation. So the second example, how old you are and your height. That is related. The older you get, the taller you get until a certain point. At some point, we stay the same height for a very long time, but there is a relation. There's some way you can connect the 2 pieces of information together. And you could actually make an equation for it. You'd have to collect some data and do some math, but you could make an equation for it. So usually we stick with a little bit simpler topic to actually make an equation for it. So welcome and thanks for joining. Currently we're talking about relations. So this relation, we want to make an equation for it. A job pays $12 per hour. Create a relation showing how much money, M, the job would pay for H hours of work. So when they do this little comma M, or say for H hours of work, those are the letters they want you to use. These are variables, and they're going to be representing the information we talk about. So M will represent the money you're going to make, and H will represent the hours of work you're going to do. So when it says it pays $12 per hour, this sentence actually gives us a way to write the relation out. When it says pays $12 per hour, pays indicates that's how much money we're going to make. That's our M. That's how much we're getting paid. $12 per hour, H means that's how many hours we're going to work. And then there's this word per. Thanks for joining. Currently we're talking about relations. I'm trying to make an equation. So the word per, we have to figure out, well, what math does that actually mean? Does per mean we're going to add? It doesn't mean we're going to subtract. I'll write it below. I'm running out of room up there. Subtract. Does it mean we're going to multiply? or does it mean we're going to divide? So let's think about the situation when you're making money. If you make $12 an hour and you work 5 hours, what math do you actually do to figure out, I'm going to make this much money total? So should we add, subtract, multiply, or divide? Multiply. Good. The word per will mean to multiply. So now we can actually write our equation. M is the amount of money we're going to make. That's our total. So then we put our equal sign, 12 times H. We just created an equation from that sentence and from that situation, that relation, because they actually relate to each other. So you can use this to predict. If you need to plan out a budget and you say, well, how much am I going to make? You can say, well, how much do I make if I work 10 hours? And then figure out the actual amount of money. So another way to write this, there's a few notation things that are a little bit different, is sometimes you have this kind of parentheses set up. Instead of just writing the letter M, they do M parenthesis H. And you actually say that to M of H. It's not M multiplied by H, and parentheses usually mean multiply. This is one of the few situations where it doesn't. The reason we use this notation is because they want you to know what the inputs are and what the outputs are. So input is the variable you're putting into the equation. If you want to figure out how much money you're going to make, then your hours is going to be your input. And we have some background noise. I'm going to go ahead and mute you unless we're actually answering questions, just so that we don't have background noise while we're trying to listen. So variable you put into the equation. In this case, that would be our hours. We know our hours first, and then we figure out how much money we're going to make after that. So output is the number or variable you get out. Of an equation. So our M of H, this notation is saying H is our input. This is the number we can pick and actually plug information in. M is your output. That's our total amount of money. That's our final answer. And that's all this notation means. So when it says something like this, M of 8, find M of 8. This is saying plug 8 in for H. Because we're using, let me rewrite the equation down here. They wouldn't just give you that, they would give you the actual equation and say find M of 8. So it just means to plug it in, and when we wrote the equation, we figured out this is multiply, so when you plug it in, you're just going to simplify that. What do we get when we do 12 times our 8? If we work 8 hours, we're about to figure out how much money we're going to make, assuming you make $12 an hour. So what output do we get when we do the actual math and the multiplication? So not seeing any answers yet. Remember, to answer, you can unmute yourself, or you can type into the chat box. You can unmute yourself and say your answer, or you can just type it in. If you're not sure what that multiplies to be, we can always consult a calculator. Most of the time, I just type in Google Calc and go to the Google calculator. Oh, we do have an answer now. Someone said 96, which is correct. Again, you can always type it in, 12 multiplied by 8. gives that correct answer of 96. So then our final answer is this 96. And in context, that means $96. You work 8 hours and you get $96. So let's do one more example and then, oh, actually, no, I forgot this page was here. This is just a general chart of all these terms that are often used to mean actual math operations. So addition, you have words like increased or more than, combined, sum. There's a list for all the different ones. I don't want to read them all to you, but you can see a lot of different things represent. This means put a plus sign here. It'll give you a sentence and you have to translate. That means plus sign. Subtraction, they can say minus, less, difference, less than, fewer. Withdraw is often used. Multiplication, of, times, per is often used. Product is more fancy. Specifically, they might say twice or triple. When it says twice, that means multiply specifically by a 2, or triple means multiply specifically by a 3. Division, it will have words like out of or quotient, equal pieces or split. Half means divide specifically by 2. And occasionally per will be used for division. Per can be kind of tricky. Most of the time, if it has to do with time, like our working so many hours, then it's multiplication. And then equals are usually words like is, are, were, will be. Sometimes you have to work with inequalities. So inequalities, you'll have those inequality symbols that look like sides of an arrow. So less than is that symbol, less than or equal to has the line underneath. And then no more than is kind of tricky. It says the word more, so we would assume greater, but it actually means less than or equal to. More than, greater than would be the greater than symbol, more than or equal to, and at least, that's our tricky one again, it actually means greater than or equal to. So with this chart, and I can, if you want me to send it to you, or if you wanted to take a screenshot, you could take a screenshot right now. Or you can even just Google what are different math words, what can they actually mean. Then we can take a sentence and create that equation. We can make that relation. So we're going to do one more example and then it will be question time. So 5 more than a number is 23. What is the number? So the actual numbers are the actual numbers. Even if it's written out as a word, that just means 5. But then we have to do some translation. What does more than mean? Is that addition, subtraction, multiplication, or division? I'll click back to the chart really quick too, so you can see we're looking for more than, and we're working with an equation since it said to solve, so it's only the top part of the chart. So addition, subtraction, multiplication, or division. Okay, still not seeing any answers, but we can see it on our chart. More than goes up and means addition. So that actual word more than translated to a plus sign. So another translation is when they say a number. Now that wasn't on the chart. When it says it's a number we don't currently know, so we actually use a variable. So I do have someone saying an answer to the whole equation, 28. You are close, and you'll see what happens in a minute when we finish the translation. 28, you're adding the stuff together instead of subtracting the numbers. And more than means plus, but it's more than a number we don't know that should equal 23. So whatever number we put here, that should take 5 plus that number up to 23. So what number would you add to 5 to make a 23? Close. So we got an answer of 16. Just be careful. Sometimes, I don't know why the 5s and 8s are hard. It is 18. We just got another answer. So 5 plus 18 would make the 23. For some reason, the 5 and the 8 taking up to 23, that's actually a common, just our brain doesn't like this particular type of addition. So when you make an equation, just because it says more than doesn't necessarily mean you add the numbers together. When we actually write the equation out, to solve something like this, you do opposites. So if we didn't have a sentence and we just had this equation, we would say, well, we're adding here and the opposite is to subtract. And when you do the opposite, it cancels it out. And you can see that the 23 minus 5 is 18. So that's why, even though it said plus, that doesn't mean you necessarily add the numbers together. You've got to write the whole equation out and decide, well, what do I do from there? Okay. So now we have general question time. What are some topics or concepts you might want to talk about that you're currently not understanding in the course? And again, you can type it out or you feel free to unmute yourself and actually just tell. So someone says they can't see the chat. I may have a different perspective than you guys. There should be a button somewhere that says chat. I have like a 3 dots that has more that I can click on. Does anyone who is seeing the chat, the button is at the bottom of the screen. So at the bottom of the screen, there should be a button that says chats that you can click on and have it show up. So hopefully you were able to figure out the chats. I am trying to say the answers and stuff as we chat, so at least you can hear the answers. Let me know if you didn't find that button, and we still have free question time. Does anyone have a particular question about whatever course you're in? We may all be in different courses, but we're trying to cover as many topics and courses that will be applicable to you as possible. I'll keep an eye on the chat to see if anyone does come up with a question. Since we don't have any questions currently, I'd say maybe talk a little bit more about equations, since we saw how to solve that equation on the last page, and because equations are used in just a lot of different topics. So when you solve an equation, as I said before, you always use those opposite operations. So right now we have this equation, x minus 8 equals 34, and it would say the instructions are to solve this equation. So our equations are split into 2 sides by the equal sign. We have a left side and a right side. And we always use those opposite operations to solve. Our goal is to get that letter variable x alone. So we want to move this minus 8 over to the other side. But to do that, we have to figure out the opposite. So right now it's currently saying x minus 8, we're subtracting. What is the opposite of subtraction? And we have our main math operations of addition, subtraction, multiplication, and division. Which one is the opposite of subtraction? Add. Very good. Thank you. Addition. So when we add with an equation, what you do to one side, you have to do to the other. And the reason we picked the opposite is because -8 plus 8, that comes out as 0. If you have a -8 plus 8, gives you a 0. It basically just cancels each other out. -8 plus 8 goes away, and then we have someone who said the final answer. On the other side, you actually do the addition. 34 plus 8 is 42. And again, feel free to use a calculator. If you don't know how to do that in your head or don't want to take the time to do it in your head, calculators are great. An option for your equations, some people don't like how messy they get and how there's so much writing. So some students choose to write the opposite over here where it matters. The 34 plus 8 is where we get our answer. And then just to cancel the -8 out. That way you have a little less writing, a little less going on. So just an option. So two other types of basic equations are when you have something like this. So this math operation is not as obvious. The addition, we saw a plus sign. The subtraction, we saw a minus sign. Here, when you have a number next to a letter, and remember, this is the letter X. It's not the multiplication symbol anymore. We don't usually use the X to mean multiply anymore because we use it so often for the variable X. So when we do multiply, usually it's a little dot. And you can put it between the number and letter. They don't write it in for you though. That 5 times X, they just write 5X and assume you know this actually means 5 multiplied by X. So you have to identify that because now we have to pick the opposite. What's the opposite of multiplication? We do have a final answer in the chats. 4 is correct, and you did that with division. Opposite of multiplication is to divide. When you do that opposite again, you can just cancel out the 5, and then you actually do the division. 20 divided by 5 is 4. So one more is if you start with a division problem. So when you start with division, it usually looks like a fraction. This fraction bar is actually now saying division. Because fractions really are just division problems that would come out as decimals. So sometimes we leave them in with the division bar because we don't want the decimal. So again, once you've identified that, now we say, what's the opposite? So what's the opposite of dividing something? Very good, multiplication. So when we do that opposite, this time we notice there's that negative symbol in front. Our opposite is opposite of division, which is multiply. So that negative actually stays with the 3. We would say times -3. And then we'd actually do that multiplication. So we got an answer of 2. 2 would be if you did division. 6 divided by 3 is 2. That's correct when you divide. But when we actually make the numbers interact, we use the opposite operation, and we want to make the numbers multiply. What is 6 multiplied by the -3? I'm going to pull out the calculator for this one. Okay, and we do have a question now. Let me finish up this topic and then we'll talk about the function notation again. So 6 multiplied by the -3 is -18. So our question is, I'm having issues with function notation. So function notation, we saw that relation example where we wrote out the function notation. Often they'll just give you a problem where they don't tell you the context. They don't tell you an actual, this is where we got the equation from. They'll just give you an equation and say, find f of -4. So again, these parentheses in this case don't necessarily mean multiply. This means f of -4. And what it's actually telling you to do is plug -4 in for the letter x, or for the variable x. So in our equation, the variable x is right there, and we want to replace that with the number. The letter x is going to go away, the number will be in its spot. We do have to remember, we saw this on the equations, what math operation is actually happening between the 2 and the x. Is that 2 plus x, 2 minus x, 2 multiplied by x, or 2 divided by x? What's there that they didn't write? Good, multiply. This is actually 2 multiplied by x. And we need to know that because when we plug in the -4, we need to know that this is going to be 2 multiplied by -4. So now we simplify this. This comes down to our order of operations, which we often remember by PEMDAS. Oops, I forgot my letter D. It is not PEMIS, it is PEMDAS. So this tells you the order to do math stuff in. We have multiplication here, and we have addition here. Those are the 2 math operations in our problem. And PEMDAS tells us which ones do we do first. Do we do -4 plus 3 first, or do we do 2 times -4 first? So it goes P for parentheses, and if there are no parentheses, you just skip it. E for exponents. Exponents are when you have that little number up above. If they don't have any exponents, we skip exponents. And then M for multiply. So when you do the actual math, multiply first. 2 times -4 is -8. Now that we've done the multiply, we can skip to division, which we don't have any. And so we go to addition next. -8 plus 3. Now this can be a harder one. When you have negatives and positives, those are harder to add and subtract. A couple ways to do it. Pull out your calculator. You can always draw a number line. This takes a little bit longer, but it helps give you a good concept of why the answer is what it is. So we start at -8, and then we're adding 3, so move forward 3 spaces, which takes you to -5. So -8 plus 3 is -5. Or you can remember the rule that when you have opposite signs, you actually subtract the numbers. 8 minus 3 is 5, but we keep it negative because the bigger number, 8, is negative. Or just plug it into a calculator. -8 plus 3, oops, helps to clear out your calculator if it had anything left. Tells you it's -5. So any more questions on function notation? Again, I'll keep an eye on the chat. Just let me know if you do have any more questions on function or notation. So I also wanted to talk today about rate of change and slope. So rate of change is the amount of change over time. This goes back to having some context. You'll know a situation often. So the amount of change over time. So when you actually find this rate of change, there's two ways to think about it. The change in the outputs over the change in the inputs. You'll see that as one of the explanations. Or there's an actual formula, y2 minus y1 over x2 minus x1. And this is probably some new notation you've never seen before, having these little numbers below. The sole purpose is that because you have two of the same letter, both letter y's and both letter x's, this is just saying the second y and the first y, or the second x and the first x. They're not actually saying you're going to multiply by 2 or do any math with the 2. This is just to differentiate between the two letters. So a situation where you'd actually have some rate of change, driving has a lot of rate of change. Your speed is considered to be a rate of change. If you're going 55 miles in 1 hour, that's your amount of change over time. You went 55 miles, you changed that amount in your distance over 1 hour. So some questions will have context like speed or saving money every month. That's how much money over how many months. Or sometimes you'll just be given a table and they'll say, find the rate of change of this table. So when we want to find the rate of change or the slope, we want to focus on this formula, y2 minus y1 over x2 minus x1. And you can call it either thing. You can say rate of change or you can say slope. They mean the same thing. So you'll see both words applying to this formula. So when you're given a table, you can pick any set of coordinates on this table. Remember that a table is actually telling you coordinate pairs on this coordinate plane. So like the -2, 3, that's saying start at the center. We call the center the origin. And it's saying go left 2 spaces because it's negative. So left 2, then up 3, and put a dot. Or the next one is -1, 7, -1, up 7. I did not make my coordinate plane big enough. So I'll just estimate the second dot would be up here somewhere. So table is just a whole set of points that you could connect together to make a relation that helps you predict. You could make an equation from this table. But all they want right now is how much does it change? So we pick any 2, and I usually just pick the first 2, and we look at them as their coordinates, this -2, 3, and -1, 7. And every coordinate is always an x value, then a y value. So that's again why we had to use these little numbers below, because I can't just call it x. I want this to be x from the first point and y from the first point, and then x from the second point and y from the second point. So once you've identified that, we plug it in. If we want to plug in y2 first, What actual number represents y2?
Hi, Ida. How's it going? I got it. Okay.
So which number should we put in this first spot for y2? What's the y value of the second coordinate?
Yes, so I got your proof of residency. For you don't have a copy of your transcripts, right? You said that you, oh yeah.
7, correct.
I do remember.
So that first spot, we put that 7. Thank you for your answer.
Yes, I remember now.
So if you're working on a problem, you could even cross it out as you go to be like, okay, I've used that 7, don't use it again.
And then when you get your transcripts, you'll be ready.
So then we have minus, and we have to go to y1.
Okay.
What is the y value of the first point?
So I'm going to text you.
3. Good. So 7 minus 3. We'll do the math in a minute because we still have to finish plugging in the formula. Next comes x2. What's the x value of the second point?
Okay. So this number that I'm calling you on, is this?
Good. -1. Let's cross out as we go. And then there's only one value left, -2. Notice here though it's minus -2 because we had minus sign from the formula and then the actual number was also negative. So when you have a negative next to a negative, that is the same as a positive 2. Negative next to a negative can just change to 1 plus sign.
I'm going to send you a text message.
So then we do the actual subtraction. We always do just the top line and then just the bottom line. 7 minus 3 gives you 4. -1 plus 2 gives you 1. Again, those negative symbols can be kind of confusing when you're adding and subtracting, so you can always just go to a calculator and plug it in. Then if you can divide, you should. 4 divided by 1 is still 4. So our final answer, the rate of change of this table is 4.
I just texted you. It should have gone to both.
So another way they might have you find the rate of change is by giving you an actual graph. If you have a graph, you have to figure out from the picture what are some coordinates I actually have. So when you're looking at the line, we want to look for the background grid, and we want to pick a spot where the background grid crosses the line exactly. This is the actual coordinate we can look at because we have two, I call them crosshairs, crossing exactly on the line. If we went to a different spot, like if I went 1 to the left, this time when I do my little crosshair, the line's not actually going through the crosshair. It's a little below it. So that can't count as a point on the line. So then to actually get the coordinate, we have to write out that coordinate pair. We have to count from the center. From that origin, if we go right to, we get right below the dot. That's our first part of the coordinate. Then we go up to, and that's the second part of our coordinate. So that coordinate is 2, 2. But we need a second one. This would be our x1, y1, our first point. We need a second point in order to find the slope. And you'll see this little letter M. That was my way of saying find the slope because M stands for slope. So another coordinate would be over here. So what would the actual coordinate pair be? How far right are we going and how far up?
7 o'clock.
4, 1. Very good. Right 4, up 1. And it's that 0.2, so x2, y2.
Awesome.
And now we go to our formula again.
Yes, ma'am.
Oh, helps if I write it correctly. That should be x1 down here. I was starting to write y. So y2 minus y1 over x2 minus x1. Again, we just go through and plug in our y values, then our x values. So what's our y value of the second point? 1. So we've used the y2. And then our y value of the first point is the 2. Good, thank you, you're correct. It's the 2. So then what do we put for the bottom? What's our x2 minus x1? Good, 4 minus 2. x2 was 4, x1 was 2. We just plugged them in. This time we don't have any minus minus situations going on, so we just do the subtraction. 1 minus 2 is negative 1, and 4 minus 2 is 2. This time, if we tried to do the division, last time we had 4 divided by 1 and it was 4. This time, if I do negative 1 divided by 2, you get a decimal, negative 0.5. With slope, we almost always want to leave it as a fraction. So we're going to leave it as the fraction negative 1 over 2.
Credits to get started, so please call me back.
So now we're back to question time. Any questions you have from any part of the course you're working on that you want some help with? While you're thinking of questions, hopefully maybe I can answer some questions. While you're working through the course, you might want to write down questions. If you're going to join, we're doing this every single week, so we'll have it again next week at the same time. Think of questions as you're working, and then you'll be prepared when you come to listen that you can ask me, okay, I didn't understand this, help me on this. Still not seeing any questions. We might end a little early today if you don't have any questions. I just want to make sure I give you plenty of time to write out any questions you might have before we end. I'll keep an eye on the chat again. Just in general, if you have questions while you're working on the course, you can always send a chat message. I think it's over on the left of your dashboard. I think it's like the need help button. Over on the left, there's a menu, and you would look for the teacher of your actual course.
Hi, Rebecca.
It'll have options to chat like your academic coaches. They're the guys in charge of what classes you still need to take. They'll have your math or science or whatever courses you're taking, those teachers. So you can get a lot of information by using that. You can also use the online tutor. There's an online tutor button over on that left side menu on your dashboard again. Okay, we did get a question. Let me finish talking about the online tutor, and I will then answer a question about equations. So the online tutor isn't going to connect you with me or your math teacher. It's just a general person. We pay another company that's a tutoring company. So they won't know, how to click through your course. They won't know when stuff is due. They will know how to answer your math questions. So if you're working and you're like, I need help immediately, I really want to get this done, you can click that online tutor button. You've got to kind of go through a little question process, and then you can actually ask your question, how do I solve this equation, or how do I graph a line? So that's another option to get help. Okay. So we did get a question of how do you do two-step equations with variables on both sides?
Okay, cool. I'll do that.
So two-step equations with variables on both sides. look something like this. There's another version. I'll do the two different versions. These can be confusing because we still need to do opposites, but we also have two variables involved. All our other equations we saw so far today, there is only one variable and only one step. Do the opposite of plus, get your answer. Here we have two variables, so we need to get the variables together. We don't like having two variables. So this 5x is currently a positive 5x. Just like they don't show that it's really 5 multiplied by x, they don't show that this is really a plus sign. We need to identify that because to get two variables together, instead of doing the opposite of multiply, doing that opposite would only do something to the 5. We want to do the opposite of the addition or subtraction to move this whole variable. So what's the opposite of adding 5x? Opposite of addition again.
So she'll be able to do her diploma online, and it is free, so there's no cost for her.
Minus. So when we minus, we're not just going to minus the 5 only, we're going to minus 5x. This is where the big difference is between one or two step equations and equations with variables on both sides. We minus the 5x to get rid of this whole entire term, and now these terms can combine together. When we combine these like terms, they're both x's, it's going to stay an x. We really just do the 3 minus 5 in front to get a negative 2. And now we've merged it into one variable. There's only one letter x in our equation now.
Okay.
So that first step, and I almost always take the right side and move it to the left. Most of the time that's possible, like 95% of the time. You just take the right variable, add or subtract it over to get it on the left side. Now we're down to a two-step equation, and we still just do opposites. We always start with this minus or plus at the end first. What's the opposite of subtracting this 5?
Yeah, that'll be the next step. I just need a copy of her transcript.
Add 5. And when we do that opposite, it gets rid of this term that we moved over. And then this was the tricky one because the number is actually touching the letter. What opposite do we use here?
I would agree with that.
Oh, sorry, and you can chat me privately. I'm getting some private chats, so I'm responding to questions you probably can't see. So we had two options. One person said +2, and then they changed their mind. They're like, well, maybe it's divide, and now we have another person saying divide.
Okay.
This is divide. This is the hardest one to remember. You're doing the opposite of how the number is interacting with the variable. 2 is multiplying by x, so our opposite is to divide by the negative 2. We're not involving the negative in the opposite, we're involving the multiply and saying opposite of that is division. So that's the last step, and it's hard to remember. It's not following the same pattern of what we all did before. So then we do that division, 26 divided by negative 2. If you're not sure what that is, throw it into a calculator. And we get negative 13.
Okay. Yeah, unfortunately then. Okay.
So let's do one more version of this.
Yeah, as far as your daughter goes, I just need her transcripts. You can take a picture of them and send them to me. So her last school will have the credits that she earned with them, and then they should have all the credits that she transferred in with as well.
So usually this is called a multi-step equation. There's a lot more steps going on. And eventually it'll look like the problem we just did, but we've got to make it look that way first. So when you have so much going on, we always take care of the parentheses first and do distribution first. Distribute. So when you distribute, you take the number in front of the parentheses and you multiply it by everything inside the parentheses. It actually kind of duplicates and is used twice.
So I want to send you an email.
We're going to do a -2 multiplied by the x and -2 multiplied by the -1. -2 multiplied by x, you can't actually do any math there. You just write them side by side. -2 times -1 comes out as +2. Negative multiplied by a negative makes positive. So now this is +2. So after we distribute, we combine like terms.
SHERLYNN201849@gmail.com.
So when you combine like terms, we have to think about how this equation is split up again. We have the left side, we have the right side. Like terms are either terms that have the same variable. 5y and 3y are like terms because they both have the letter y. Or -2x and 10x, those are like terms because they both have the letter x. Or numbers with no variables, those are also like terms. 5 and 13, those are like terms because they don't have any variables. So we look at both sides and we say, are there any like terms on the left? And are there any like terms on the right? So no like terms on the left. This has an x, this doesn't. What are the like terms on the right side of the equation? So remember, we're looking for two things that have the same letter or two things that don't have a letter at all. What are the like terms on the right side? So not seeing any answers yet. So we have a -2x, that's one term. We have the +2 and a +3. These two things are like terms because they both don't have a variable. 2 and 3, no letters at all. We can combine them together, which is different than solving. When we solve and move stuff to the other side, we do opposites. When we combine like terms, we just combine what's already there. 2 plus 3 is 5. So those two numbers combined together to give us a 5. We didn't have to do the opposite because they're already on the same side. Now we move to opposites. So we're going to take the x term on the right side and add or subtract it to the left. We have to be a little vague here because you might need to add it, you might need to subtract it.
Hi, Amy. My name's Katie. I'm calling
depending on what sign it already has. Sorry, it's really hard to write with a mouse. I apologize that sometimes it's hard to read. So our right side has the -2x. We want to do the opposite to move it over. So what's our opposite of a -2x? I think maybe we're all getting a little tired after talking about math for an hour, so still not seeing any answers, but I'll go ahead and tell you. Opposite of minus 2x is add 2x. And you actually do the combining on the side you moved it to. 4 plus 2 is 6. Then we take the plus 1 and do the opposite to move that to the other side. The end is always just to do opposite operations. Once you've got it down to this two-step equation, you just do opposites. So opposite of adding 1 is minusing 1. 5 minus 1 is 4. And then this was our weird, tricky one. Opposite of having 6 next to x is to divide. It's actually multiplying here. They just don't show it. You have to know that it's multiply in order to do the opposite of division.
Hi, Brenda. Hey, how are you?
So 4 over 6.
Great.
You might need the decimal this time. Your answer might be written as a decimal. Or you might need the reduced fraction. The decimal is this 0.66666. Usually when it's written as a decimal, I've asked you to round to the nearest tenth. So this number here, if you're rounding to the nearest tenth, either stays a 6 or rounds up to a 7. And we determine that by the number next to it. This number, because it's between 5 and 9, tells us round up. This will become 0.7.
It's 313 576.
So thank you for joining me today. If you have any more questions, please contact your teacher. You can use the online tutor as you're working. If you want to send me an email and ask me a question, my email is april.barton@graduationalliance.com. You can even ask your academic coach and they can give you resources. Lots of people are here to help you out as you're working through because we want you to get through the course. We will be doing these every week, so if you have more questions, you're welcome to join us next week at the same time. So thanks guys and have a great day.